colleague Eva from the Society of Biology is also here with me. And I'm going to take you through a few random bits of STEM, essentially. So there isn't enough time to go through all the various initiatives or organisations, but I'm just going to highlight a few points and also areas. And as my area of expertise is physics, so it is a little bit physics heavy, but I do bring in the other sciences as well. So just to start off with, the organisations. So I'm from the Institute of Physics. There's a number of organisations, and these are essentially, I suppose, the expert organisations for these various areas. So essentially who to contact if you have a question relating to chemistry or chemistry careers. It's the Royal Society of Chemistry, Society of Biology, Mathscareers, which is a website that is designed to illustrate the careers from maths, which is a number of maths organisations working together. In a similar way, Society of Biology is a combination of a number of biological societies. On this side you have Engineering UK, which is the umbrella organisation for engineering, and also representing 36 different engineering organisations. My colleagues just handed you this leaflet which lists, as you can see, and that's not all of them, that's some of the engineering organisations there. So it's various organisations for different sectors that represent STEM, and we are a learned societies. So our other role is also to, for example, the Institute of Physics to accredit degrees. In a similar way, the Royal Society of Chemistry accredits degrees, and that's to keep the quality and the content of degrees to the prescribed level. For engineering, it's the Engineering Council, and these, I know that, for example, the Engineering Council allows you to search online for all accredited degrees. These are becoming more and more important, the fact that, particularly for engineering, if you want to be a chartered engineer, which is very important in progressing through the engineering profession, it certainly has to be an accredited degree to be eligible. In a similar way, for our professional accreditations and titles, you need to have studied an accredited degree. So, just so that if you aren't aware of these organisations, just so that you are now aware. Also, there's the organisation on the top right there, STEMnet, and essentially the best people to contact if you want people to come in and do a talk or to help out in terms of a scientist is STEMnet. It's run, it's a biz-funded organisation, and there's, I can't remember the numbers, but many thousands of volunteer scientists that then go into schools, for example, and help out either with teaching or to give careers talks. So if you're looking for people to come into in any sense, STEMnet are the people to contact. One, we're very keen to obviously push science because, as you can see, science opens up your options. In terms of number of degrees, this is from the Russell Group report that was published last year, I believe. And if you go through and count up the number of times different subjects at A-level are mentioned as being essential for continuing to study, you can see number one is maths, then all the sciences, and there's a big drop between those and the remaining subjects. And the other thing that is really worth pointing out to students is, for example, law does not appear there. To study law at university, you do not need A-level in law. In a similar way, psychology does not appear there. So, it's not always obvious to the students, if you're dealing with GCSE students, that the subject that seems to have the name of the thing they want to study is not the correct subject to study. Or, certainly not, perhaps not the wrong subject, but as the advice given by the Russell Group reflects, it's essentially choose two of the facilitating subjects, as they call them, which are maths, English, physics, biology, chemistry, geography, history, and languages. And as they point out, that these, if you don't choose two, you're shutting the door on essentially a Russell Group university. Okay, I realise this is only the Russell Group, but it certainly illustrates the point that science will give you the most further study options there. And excuse me. And certainly when I've talked to students, very visual representation of this works. And if anyone needs some slides, please do get in contact. I'll leave my email address at the end, or our email address. So it does illustrate the point that to carry on into areas that you may not consider need science, you do actually need science. And all the report actually lists each of the degrees and what they recommend in terms of A-levels. One thing that the Institute of Physics certainly is concerned with, and the engineering organisations, is the number of girls that choose to continue with physics. In general, you can see that science is starting to pick up. This only goes up to 2010, and the picture's got better as, in the last 2 years as well. So you can see that what's happened is physics, for example, has dropped off. Maths has seen a rejuvenation. It's certainly started to climb, both maths and further maths there. So although this represents the number of girls, the proportion scales. So for physics, for example, it's remained stubbornly at 22%. And that's despite all our work, which is a bit concerning, but at the same time, the work has revealed why. And the work is interventions in schools, teachers changing their approach to teaching, and also how to present the careers that are available via physics. And it's really important, for example, so let me just show you another slide that illustrates possibly what goes wrong in either careers advice or in school teaching. So for example, in the UK, and it is a UK problem, it's not a global problem. For example, in Italy, the number of men and women in physics is roughly the same. In many other countries it's true. I think France is a similar sort of ratio. So it's something to do with the UK and something to do with the culture in the UK. And it's the gendered image. It's very much physics is for boys, engineering is to do with oil and spanners. In fact, modern engineering is nothing like that. So it's still this image that persists. And there was a very interesting study by run by King's College, looking into the aspirations of young boys and girls. And the message is getting through that science is very useful, and they will regurgitate that message, the students, but they won't believe it, because if they delve deeper and the identity that girls have doesn't fit in with how they see engineering and physics. So it's clearly we as a community need to get the message across that STEM isn't this image that they have of scientists or engineers. Another study, this was the Rose study, that looked across 20 different countries into what boys and girls want to learn in science. And I suppose it's what you perhaps would expect. So boys, things that explode, space, atom bomb, so things that explode even more, biological and chemical weapons, which always worries me, and then black holes, supernova, and other things in space. While for girls, from what they want to learn in science is why we dream, cancer, and how to treat cancer, how to perform first aid, health, so the last two fall under the health. So there is a stark contrast. Now, doesn't mean that physics doesn't address those questions, or engineering doesn't address those questions, but the approach is important, clearly, to match the needs and to find out, speak to girls and find out what interests them, and then making sure your approach to those subjects and those careers do actually meet with their own view of the world. So, for example, what we found works well in terms of tackling gender bias, and it really can be a dramatic effect in a particular school. Just a teacher changing their approach to the examples they use in a lesson, or the type of careers you illustrate. It can really make a dramatic difference. So, one way of tackling gender bias is to highlight STEM careers, for example, that deal with subjects such as tackling poverty, health, or environmental issues. So this seems to work. This is something that then girls start to identify with. And also, it's very important to manage activities. It's not a lot of work to manage the activity in a gender-neutral way, but without thinking it through, and I'm certainly been guilty of this. Before I worked for the Institute of Physics, I was a teacher, and now reflecting back, I can see that I did this without thinking. My teaching was gender-biased by the examples and the careers I highlighted. They're more likely to appeal to girls from the previous slide. To boys from the previous slide. So, if you're doing a careers event, for example, it's important to ensure that girls participate. One way of doing this is to consider single-sex groups, but that's not always the right answer. The other is to ensure that the boys don't speak over girls. They tend to do this in science more than other subjects, it appears. So you could have a system of questioning and answering that everyone gets involved with. It's important to encourage role models, for example, from STEMnet that may come in to brief them and ask them to personalise their experience, including talking about the family and life in general. And also to challenge stereotypes. I know this is regurgitated many times, but there's many different ways of challenging stereotypes. One, for example, that we developed is to do role selection by skills. Because the problem can be that if you say the word engineering, that's it. The shutters come down, I'm not listening anymore. And so we've developed an activity, I'll move on to this in a minute, that does role selection by skills rather than the title of the job. And then you tell the title of the job afterwards, and they've given it a chance to learn about it, then they can make an informed decision rather than just completely the shutters coming down. So some areas, some websites that we've been developing and my colleagues have been developing to hopefully give examples of careers and that engineers do, that physicists do, and science in general is physics.org. These are all students, targeted at students. Physics.org, Tomorrow's Engineer, and Futuremorph. So this is an example that we've come up with. It's certainly just one way of approaching this stereotype problem. So the activity involves planning a music festival, and you take on different engineering roles, and you ask the students to work in teams of 6, and you say, right, okay, please choose your role. So the decision is the students, they discuss amongst themselves, and then they look through the skills, they learn about the skills that these roles will involve, and then you reveal the skills. And you end up with these various roles. We've tried it the other way around, and you will find the boys go for the engineering, everything that says engineering and the boys will do, and the girls will stay away from. I'm generalising obviously, but it really does happen. While if you do it the other way around, you ask them to think about the skills, then you do get girls taking on different roles, trying out, for example, being an electrical engineer in the planning of a music festival and working together as a team. If you're more interested in this activity in general, please drop us an email and I can send you a pack if you're thinking of running it. It's a full day off timetable activity, which you bring in STEM ambassadors, for example, and they help the students plan a music festival. So it's a vehicle, rather than just your traditional careers event, say speed dating, it's a vehicle for students to speak to scientists and engineers, and then through that they can actually learn about engineering a bit more. So, and one important reason to encourage more girls to do physics and engineering is that they are locking themselves out of higher paid jobs. So this, the data is a little bit old, we haven't repeated this, but this is a survey of graduate earnings by different subjects, and this was 2004. So this is funded both by us and the Royal Society of Chemistry. As you might expect, medicine and law come out top, but engineering and physics, chemistry come out really well in comparison. The biological sciences, although they look like they're not doing too well there, it's a little bit more complicated because it's a mixture of all the life sciences, so it's unclear, and in fact 10% of all degrees can be qualified as life sciences, so the picture's less clear with the biological sciences, but you can see that other than law and medicine, as you would expect, those are the highest earners on average. Engineering, physics, chemistry does come out well, and so does biology, or some areas of biology certainly. So another important message to get across, and probably even more important, it doesn't mean that they're being physicists. They're using their physics skills, or using their chemistry skills, or using their engineering skills. For example, physicists, a large portion of them used to at least go into finance. So you possibly got physicists to blame for some of the mess that we're in right now. So what physicists can do is they can model, they can predict things. Clearly the models aren't quite working quite right in finance, in a global sense. The assumptions that they used were slightly off. and that's caused a few problems, obviously. But the point being that it's important to say that this doesn't mean the degree doesn't lead to the job that it seems to indicate. Alternative qualifications. So these, there are people that work in science without going to university. And some people that work in science that do not have any formal qualifications in science. And the Society of Biology and various other organisations have realised that it's important to recognise that this is an important area, and certainly there's people with lots of experience out there that that should be recognised. And so this is a new registration, so registered science technician, registered scientist, and the sort of level that these correspond to are shown above. Or equivalent job training. So these can be awarded to technicians that work and support pharmaceutical companies, for example, in all areas. So this is a new route new way of recognising the professionalism of people that may not have gone through the more traditional routes into science. There are a growing number of apprenticeships, both not in physics in reality, they're more in engineering, in the sort of physics engineering area, and certainly in biology and chemistry. So just a few examples of apprenticeships that are currently available from in biology. And the Tomorrow's Engineer website provides some useful advice to students considering apprenticeships. And some of the biggest providers in this country are sort of there. Okay, so the hard bit, I think, always is when dealing with students is how do you illustrate transferable skills? And I'm just going to show you a little exercise, and in fact I'm going to ask you to do the exercise. And as I always say to students, there's no right or wrong answers. But the important thing is to discuss the job roles, think about them, ask questions about them if necessary, and then put them into what you think is the right order. So there's various ways of doing this. You can do it in different shapes, but let's just do it in a straight line. So Eva is going to, has done or will do, handing out now some post-it notes. I've colour-coded them so I can see them from a distance. So I just want you to work in a group of 4 or 5 and discuss amongst yourselves for 5 minutes and then put them onto the line of how you view them as more physics or less physics. Now the question is, what do you mean by physics? Is that physics qualification? Is that physics knowledge? So please just discuss amongst yourselves, so, or the four that you are nearest to, and put them in a line, and as I said, there's no right or wrong answer. The important thing is to just talk through. Try to use the same colour. The post-it notes should be coming back. Just take one of each colour, please. Okay, I'll give you one more minute. Unfortunately, we're running out of time. Okay, could I just ask you to hold up your answers so I can just get a general view of... Okay, so... Right, that seems to be completely different for everyone. Okay, well, as I said, there's probably not right and wrong answers, but in terms of physics, the way I personally do it is I think I put electrician all the way over here. I'll explain my choice. You can argue with me. Architect I'd probably put next, but it's probably interchangeable. Electrician could be that way around, or architect could be that way around, I'm not sure. But probably weather forecaster is going to be at this end. And I haven't got room to move the other two. Computer game designer I'd put near weather forecast, and pattern turning I'd probably put in the middle. Now, the reason that I'd probably do it that way around is weather forecasters are either maths or physics graduates. They tend to be maths or physics graduates, and they do need to understand complicated modelling. And sometimes they get that wrong as well, as you've seen. However, forecasting the weather is very complicated. It's such a complicated system to actually model. Computer game design. Now, the highest earners in computer game design are physics graduates, because computer games no longer are animated. They literally are virtual environments. So you have to program all the rules of physics in and let the computer game work it out. So they literally are not told what to do, the characters in a computer game. They're told the rules of physics, you need to program them, you build up each character out of vector areas, and then they react to their environment. There literally is another world inside that computer game. And as I said, the highest earners, we did a recent survey, the highest earners are physics graduates in computer games. So. Pattern turning depends on the type of pattern turning. If it's physics or engineering based, then clearly you need at least a degree in physics and then further qualifications. The reason I've got electrician in there, an architect, yes, you need an A-level in physics. How much physics you use, well, it depends on which end of architecture you're at. The more civil engineering end, you use more physics, the other end, less so. Electrician I put in there because that, for most GCSE students, is what they think physics is. They think, oh, it's bulbs, it's connecting the wires. Electricians, I mean, I'm probably generalising, and I apologise if anyone knows an electrician that is different to the one I'm about to describe, are unlikely to understand all the ins and outs of the physics. It's a bit more engineering perhaps, and certainly the application. I couldn't wire a house, for example. I understand the theories, but so that's why I put electrician that side. It's using some of the knowledge, but hardly any of the skills that physics develops. Physics is more about the modelling, predicting, and being able to use mathematics to predict what's going to happen next. And that can be in the physical world, or in a virtual computer world, or in a complicated, chaotic system, such as the weather systems. So it's important to get this across through examples of how physics applies to so many different areas, and why physics, and I haven't even put finance up there. So finance is another big employer of physicists, or certainly was. It's obviously declining a little bit now. The point of this exercise isn't to get it right or wrong. The point is to start the debate, and it certainly, I think, is a good way of starting the debate about transferable skills, because otherwise, how do you approach this? What does a physics graduate do? Becomes a scientist. That's the usual view that a student has, becomes a scientist. That's it. While if you explain about computer game design or medical physics, for example, and how all the technology that's used in PET scans and MRI scans, how that was developed by physicists that work in hospitals and is operated by physicists that work in hospitals, it starts opening up their students' eyes to all the different applications of both physics and engineering. Okay, just to finish off. There's also, if I had time I would show you one of these videos, but unfortunately we are out of time. At the National STEM Centre, we, both the IOP, the Science Council and Futuremorph and the Royal Society of Chemistry, for example, have lots of videos to help illustrate both careers in science and careers from science, such as becoming a patent attorney. So these are all stored on the National STEM Centre, which is a growing database of STEM resources, all online, and it's continued to grow. So if you haven't had a look yet, please do. There's lots of videos. Last time I looked, there's at least 172 careers resources on there related to science. And finally, who to contact. So STEMnet is across the country, as are most of our organisations. We although most of us are based in London, we have regional representatives across the country as well. So those are the people to contact via, if necessary, these general email addresses to then get in contact with your local representative. So Education at Society of Biology, Education at RSC, Education at IOP, Mathscareers at ima.org, and careers@engineeringuk.com. So if you have any questions, apparently we should move to the speaker's corner to answer any questions. So I'm more than happy to answer any questions you have back over there. So thank you.